Hi, these are the fundamental trigonometric identities we are using to prove whether the given is an identity or not. So these are the reciprocal identities, quotient identities, and Pythagorean identities. And since these left and right are equal, then that would mean we can replace one with the other and vice versa. So let's work on your learning packet, activity 2, which is an enrichment. So let's work on the first one. Okay, so the first one, tangent x times sine x plus cosine is equal to secant x. So the tangent can be written as the quotient identity sine x over cosine x times, copy this part, sine x and also cosine x. We need to show that the left side is equal to the right side. So we work on the more complicated side. And another technique is that we turn everything to sine and cosine functions. Okay? Then applying the rules on fractions. So this part, sine x and sine x, can be put together as sine squared x over cosine x. So multiplying the numerator part plus cosine x. Then now applying the LCD, the rules on addition of fractions. So this is over 1. And that makes the denominator cosine x. So we put the denominator cosine x. And then the numerator of the first fraction is copied sine squared x. Then, of course, since we have changed the denominator of the second fraction to cosine, so that would mean we multiply this by cosine x, we shall also multiply its numerator by cosine x by the rule on equivalent fractions. So the numerator becomes cosine squared x. Now, notice that the numerator is a Pythagorean identity that is equal to 1 over cosine x. Because the numerator is sine squared plus cosine squared, it is equal to 1. Then, we see that this is a reciprocal identity of secant x, showing you that the left and right side are really equal. So, we shall say that number 1 is an identity. Now, let's move on to the next example. So, for number 2, here, one technique again is to turn everything to sine and cosine. Okay, so, and then apply the rule on LCD. Okay, so, this is 1 over changing the tangent to its quotient identity sine x over cosine x plus the tangent turning into sine x also cosine x. Now, the left side, I'm choosing the left side as the more complicated one. Maybe because there is a fraction. That's why I'm working on it. You may either work on the left side only to show the right side, or work on the right side only to show that it's equal to the left side. But there is also another technique wherein you work on both sides and end up with the same expression on the left and right, provided that you wouldn't transpose or mix the left and the right side. Okay? So here, I shall work on the left side, and the first is a fraction, so that can be written as the reciprocal of sine x cosine x. So cosine x, so division by division of fraction. Cosine x, we take the reciprocal of the denominator, which is also a fraction. So cosine x over sine x, then plus sine x over cosine x. Notice that this is still a plus, and that's not yet a product, just like the one on the right side. Now, we will be finding the LCD again, which is the product of sine x and cosine x. So this is the LCD. And so by the rule on fractions, we change the denominator, so we shall also change the numerator. So the denominator LCD sine x cosine x divided by sine x multiplied by cosine x. So that's one way of doing it. Another way is to multiply the denominator sine x with what is missing to get the LCD. So multiply this by cosine x. And we shall also multiply the numerator by cosine x. So technically, you are multiplying the whole fraction by cosine x over cosine x, which is one whole. So that's why the numerator becomes cosine squared x. Then the same thing goes with the second fraction. So multiply by sine x to get the LCD, but again, to maintain the equivalence of fractions, we shall also multiply the numerator with sine x, which makes the numerator sine squared x. Then notice again that the numerator is a Pythagorean identity to 1. So sine x times cosine x. Now, we can separate this to as 1 over sine x times 1 over cosine x by the rule on multiplication of fractions. Now, notice that these are reciprocal identities of cosecant x times secant x, which shows the right side. And so, number 2 is also an identity. Okay? So, now let's work on number 3. In number 3, we will be applying factoring. So, notice that there are two terms on the left. I'm working on the left because it looks more complicated. Okay, so you work on the more complicated side. Then we factor the common part, which is sine x. So the first term becomes 1 minus the second term becomes cosine squared x. Now, the second factor looks familiar. It came from the Pythagorean identity. So it could be written as sine squared x. Okay? And notice that when you put these two together by product, it becomes sine cubed. And that's not the same with this one. And there's no way that they become equal. And so we shall say that this is not an identity. Alright? So, explaining further how this became sine squared, because it came from the Pythagorean identity that says sine squared x plus cosine squared x is equal to 1. When you transpose the cosine squared to the other side, sine squared x is equal to 1 minus cosine squared. So they are equal, and so one can be replaced by the other. Now, you might be wondering why we transposed here. Because this is already a proven identity. Okay, accepted that this is an identity. But when you're just proving, whether the given is identity, you cannot transpose. You cannot mix the left and right. So you either work on the left side to make it look like the right side or work on the right side alone to make it look like the left side. You are also allowed to work on both sides at the same time, but without mixing them up. So you're not allowed to cross multiply nor to transpose. Okay? So that's it, and watch out for more examples next time. Thank you.